example 1.6. Example 1.6. Okay, go through that. Example 1.1.6, problem number A. Problem number A. Go through it. See, this is your question. Example 1.6, problem number A. Anyone got the answer? Calculate the number of degrees of freedom. Any answer? Abhaya?
So,
Abhaya, what is the equation to find number of degrees of freedom?
n equal to 3 into L
3 into?
minus 1 minus 2j L minus 1 minus 2j minus h.
H. Then what about number of links in the first question? That is A. Number of
5.
links, 5. What about number of joins?
6.
Is it 6? Sure.
Yes.
So you have two binary joins and two ternary joins, right? രണ്ട് ബൈനറി ജോയിന്റും രണ്ട് ടെർണറി ജോയിന്റും ഉണ്ട് ഫിഗർ 1.6a. So total number of joints, Abhaya പറഞ്ഞ പോലെ തന്നെ, it is 6. So what about number of degrees of freedom? Abhaya?
0.
0. Okay. When you substitute in the equation is n is equal to, or number of degrees of freedom is equal to 3 times inside the bracket n minus 1, where n is the number of link, minus 2j minus h. So number of joints, it is clear from the figure, number of joints is 6 and number of links is 5. So first question, it is very simple question. First one, very simple question, and you will get number of degrees of freedom as 0. So anyone, all the 49 should understand this problem. It is very important for your mid examination and university. So any doubt, anyone having any doubt in the first one, 1.6a, you can ask now. Okay, we will clear all the doubts and will go. Everybody should understand the problem, how to solve the problem. Okay, anyone having any doubt in first one, 1.6a? If there is no doubt, we will move to the next question, 1.6b. Figure 1.6b. Fatima Hiba. Fatima Hiba. Fatima Hiba. Fatima Hiba. Vishnu Priya. Vishnu Priya. Vivek. Vivek.
Yes, sir.
Vivek,
Yes, sir.
what about the second question? Number of links. Number of links.
Sir, number of links 2.
Second question, figure 1.6b. What about the number of links?
Sir, 3 links.
Only 3 links. See, Vivek, so imagine there is no slider. There is no slider. It is just like a simple triangle. Okay. Then what about the number of links? Question is this, it is not this one. You just imagine a triangle. Okay, that is your question. So what about the number of links? ഒരു ട്രയാങ്കിൾ ആണെന്ന് വിചാരിക്കുക വിവേകെ. സോ നമ്പർ ഓഫ് ലിങ്ക്സ് എത്രയായിരിക്കും?
3 ആയിരിക്കില്ലേ സർ?
3 ആയിരിക്കും. ഓക്കെ, ഹിയർ now look at the question. Here, in addition to that triangle, there is one more component, that is your slider. You can see at point 4, you can see that slider. So in addition to that, one external member is there, that is slider. This is an example for slider crank mechanism. This is slider, fourth one. So what about the number of links? Number of links.
4 ആണോ സർ?
Yes, number of links is 4. This is the mechanism you have studied. Slider crank mechanism in the simple figure another. This is slider crank mechanism, and number of links it is equal to 4. Here you have 3 turning pairs and 1 sliding pair. 1 sliding pair. Then what about number of joints, Vivek? What about number of joints?
സാർ ആ സ്ലൈഡർ കൂടെ കൺസിഡർ ചെയ്യുന്നുണ്ട്.
സ്ലൈഡർ കൂടെ കൺസിഡർ ചെയ്യണം.
4 ലിങ്ക്സ് ആണ്.
4 links ഉണ്ട്. What about number of joints?
4 joints അല്ലേ സർ?
Yes, 4 joints. So in order to remember or understand the concept, just first of all consider a simple figure, like similar question with all just a triangle you consider. So in that you have 3 links and 3 joints. Now you are adding one more component, that is one more machine element, that is your slider. So one more link is there, slider, and in order to join that one more joint will be there. So 4 links, 4 joint. Then what about number of degrees of freedom? Number of degrees of freedom.
Sir, n is equal to 3
into
L minus 1 minus 2.
So what will be the value? Value will be എത്രയായിരിക്കും വിവേക്? ആൻസർ, ഫൈനൽ ആൻസർ.
സാർ ഒരു മിനിറ്റ് ഒന്ന് കാൽക്കുലേറ്റ് ചെയ്യാം.
സാർ ഇതിലാ 1 നമ്പർ ചെയ്തേക്കണം മാറിപ്പോയേക്കണാണല്ലേ? ഇതിലാ 1 മാർക്ക് ചെയ്തേക്കണ അത് ശരിക്കും ഇപ്പറയല്ലേ വരണ്ട? ട്രയാങ്കിളിന്റെ തേർഡ് സൈഡ്.
ട്രയാങ്കിളിന്റെ തേർഡ് സൈഡ്, ദാറ്റ് ഈസ് ഫിക്സ്ഡ് മെമ്പർ.
യെസ് സാർ.
സാർ ഡിഗ്രീസ് ഓഫ് ഫ്രീഡം 2 ആണോ സാർ? ഹയർ പെയർ 0 അല്ലേ?
0. ഹയർ പെയർ 0. നമ്പർ ഓഫ് ലിങ്ക്സ് 4. നമ്പർ ഓഫ് ജോയിന്റ്സ് 4. So what about degrees of freedom? Just substituting the equation. 3 into 4 minus 1 minus 2 into 4. 3 into 3 9 minus 2 into 4 8. 9 minus 8 1. അതല്ലേ ആൻസർ വരും വിവേക്?
സാർ.
See, 3 into 4 minus 1, where 4 is the number of link, and minus 2 into 4. 4 means number of joints. So now you look at the figure C. Figure C. Okay, look at the figure C. Anyone who can say, directly say, looking at the figure and substituting the values, can you say what will be the number of degrees of freedom? All of you calculate.
-1.
Yes. Answer is -1. See, look at the figure C. there you can see it is clear from the figure number of links is equal to 6. And whenever you calculate the number of joins, in that figure you can see 4 ternary joins are there. Ternary joins. ഒരു പോയിന്റിൽ തന്നെ 3 connections. 4 ternary joins are there. So 1 ternary joint is equal to 2 binary joins. 1 ternary joint is equal to 2 binary joins. So you will get total number of binary joins as 4 into 2, that is equal to 8. 8. And number of links 6. So number of binary joins is equal to 8 and number of links is equal to 6, and your degrees of freedom will be -1. Degrees of freedom will be -1. That is very simple and direct question. What about figure D? Figure D.
0.
Figure D. Look at the figure D. You can see total number of links in case of figure D. What will be the total number of links? Total number
5.
of links in. It is not 5. Look at the figure. Figure 1.6D. 6. It is clear from the diagram. Number of links is equal to 6. Okay. Then what about number of joins? What about number of joins in 1.6D? What about the
6.
number of 6? Yes. So number of links is equal to 6. Number of joins is equal to 6. What about degrees of freedom?
The
Degrees of freedom? 3. Yes.
3.
3. Yes, yes. Number of degrees of freedom will be 3. So C and D are a little bit direct questions, very simple questions. And now you look at the most important question, E. Look at E. E. Can anyone tell, looking at the figure, what will be the number of links?
3 അല്ലേ sir?
Number of links?
3.
Yes, number of links is equal to 3. For that, you keep in mind, see, from no textbook you will get this concept. Every fixed member, here you can see 2 fixed member, you can see the hashed region, 2 hashed region you can see in this figure. Okay, all the fixed members, they are treated as single link. Okay, all the fixed members, they are treated as single link. So that is why 1 is written here and here. Okay, 2 sides you can see 1, because all the fixed links, they are treated as or counted as 1 itself. So if there is one more fixed link, you will number it as 1 only. Okay, all the fixed links, they are treated as 1, counted as 1. So number of links will be 3, which is clear from the figure. What about number of binary joins? What about number of binary joins?
2.
Number of binary joins is 2. Very good. So if you are able to understand where is that 2 binary joins, then everything is clear. You can solve every questions. Anyone who can identify where is that 2 binary joins? Anyone?
Sure.
Where is that joint? Two binary joints ഉണ്ടെന്ന് പറഞ്ഞു. Where is that 2 binary
Fixed
joints?
position. Fixed.
Yes,
Fixed link.
yes, very good, very good. See, 2 binary joints are at the fixed positions. Fixed link ഉള്ള പൊസിഷൻസിലായിരിക്കും 2 binary joints. Only 2 binary joints are there. So what about the connection between link number 2 and link number 3? What about the connection between link number 2 and link number 3?
Higher pair.
Higher pairs. Yes, that is the concept. Everything is solved. Okay, so many concepts are there in the figure C. Rest A, B, C, and D are simply mathematics, pure mathematics. By looking at the figure, easily you will get all the things in A, B, C, and D. But E consists of, question number E consists of concepts. Okay, so first thing is you have to remember all the fixed links, they are counted as one link only. All the here you can see two fixed links are there, so they are counted as one only. And you can see the other two links also. So you will number the links as 1, 2, and 3. Total number of links will be 3. Then next is about the number of binary joins. So in the fixed link, there will be one binary. So there are actually two fixed links, and it is counted as one since it is fixed. So there will be two binary joins at the fixed positions. Next is the connection between 2 and 3. It is just like a point contact or line contact. So in that case, it forms connection between 2 and 3. It forms higher pair. So your higher pair is there in this question, and higher pair, total number of higher pair, that is equal to 1. Total number of higher pair is equal to 1. So in this question, number of links is equal to 3. Number of binary joins is equal to 2. Number of higher pair is equal to 1. What about the degrees of freedom?
1.
Degrees of freedom is equal to 1. Degrees of freedom is equal to 1. So that is, so mark it as a very, very important question. 1.6E. Mark it as very, very important question. Then go to F.
Sir, higher pair കണ്ടുപിടിക്കണമെന്നോടൊന്ന് പറഞ്ഞുതരാമോ?
Higher pair കണ്ടുപിടിക്കാനായിട്ട് just you have to remember the difference between higher and lower pair. What is higher pair and what is lower pair? That already you have studied. Whenever there is point or line contact, പോയിന്റ് അല്ലെങ്കിൽ ലൈൻ കോണ്ടാക്ട് വരുന്ന കേസിൽ ബോൾ ആൻഡ് റോളർ ബിയറിംഗ്, when you see the ball and roller bearing just touch ചെയ്ത് പോവാ, cam and follower, that all belongs to higher pairs. Cam and follower, ball and roller bearing all belongs to higher pair. Then you consider nut and bolt. There is surface contact. You just consider your simple example. Just consider nut and bolt. There is surface contact. Okay, there is surface contact. That belongs to lower pair. Surface contact ഉണ്ടെങ്കിൽ that is your lower pair, and whenever there is point contact or line contact, that is your higher pair. Okay. So go to the figure F. Figure F. What about number of links?
4.
Number of links, it is 4. Then what about number of joins?
D.
Number of joins. All of you look at the figure F. Number of joins is equal to number of joins, that is equal to 3. Then anything else?
Higher pair.
Yes, that is the concept. Okay, one higher pair is there. Here you can see one wheel. Okay, so the contact between wheel and the link number 1, that forms the higher pair. Contact between wheel and the link number 1, that forms the higher pair. And you can see 3 joins. It is clear from the figure there are 3 joins, 3 binary joins, 1 higher pair, and 4 links. 4 links. Okay, 4 links. Then what about degrees of freedom?
2.
Degrees of freedom? 2. Yes, good. Degrees of freedom 2. So whenever you study some things, you concentrate on the question number E here. So in this total of 6 questions, you have to focus mainly on the question number E. It consists of so many concepts. Rest all are very simple questions. If other questions are asked and you are unable to answer, means your knowledge is very poor. Okay, so that means that much simple. All the other questions are that much simple. Nothing, just to substitute in the equation. That's all. But figure E, that is very, very important. Okay. So go through this. Then next section is, I hope this was the question given. Determine the degrees of freedom in the mechanism shown in the figure A to E. Right? ഇതല്ലേ പിന്നീട് തന്നിരുന്ന question? Vivek, Akshay,
അതെന്ന് തോന്നുന്നു സാറേ, ഞാനിത് ചെയ്തിട്ടുണ്ടെന്നുള്ളൂ.
അതല്ല ഇതല്ലേ ക്വസ്റ്റ്യൻ വീണ്ടും തന്നിരുന്നത്? ഒരു എക്സസൈസും കൂടി തന്നിട്ടുണ്ടായിരുന്നില്ല നിങ്ങൾക്ക്? Okay, now look at the figure. Abhirami Bhaskar.
Yes, sir.
Abhirami, look at the figure 1.7a. What about number of links?
6 അല്ലേ?
How you can say it is 6?
6 ലിങ്ക്സ് അവിടെ ഫിഗറിൽ കാണുന്നില്ലേ?
ഫിഗറിൽ ഞാൻ നോക്കിയിട്ട് 6 ലിങ്ക് അല്ല, അതിൽ കൂടുതൽ ലിങ്ക് കാണുന്നുണ്ടല്ലോ. You can see 2 triangles. 2 triangles means already 6 link ആയി. Then 7, 8, 9, 10. There are 10 links, right?
Yes.
Okay, 100% sure. Abhirami,
Yes.
10 links are there, right?
Yes.
But you are wrong. That is the concept, okay? She is wrong. Why? Because a triangle, when it is shown in a hatched manner, okay, the figure you can see the triangles in a hatched manner, that represents single link. That represents single ring. That is why one is written there. Okay, so triangle with hatched sections, that represents single link. So one is that triangle, that is one link, and that triangle 3, that is another link. So what about the total number of links? What about the total number of links, Abhirami?
1 ആയിരിക്കില്ലേ?
ഒരു ട്രയാങ്കിൾ ഹാച്ച്ഡ് സെക്ഷനിലുള്ള ഒരു ട്രയാങ്കിളിന് അത് ഒരു ലിങ്ക്, അതേപോലെ വേറൊരു ട്രയാങ്കിൾ ഉണ്ട്, അത് വേറൊരു ലിങ്ക്. Then other links are there. So total number of links will be 6. Total number of links. Abhirami മനസ്സിലായ? ഒരു
ട്രയാങ്കിളിന്റെ 1 ആക്കിയിട്ട് എടുക്കണം.
So two hatched triangles are there. 2 links അങ്ങനെ തന്നെയായി. പിന്നെ you can see the other 4 links. So total number of links will be equal to 6. Then what about Abhirami? What about number of joins?
ഇതും ട്രയാങ്കിളിന്റെ ജോയിൻസ് ഒക്കെ അങ്ങനെ എടുക്കേണ്ട ആവശ്യമുണ്ടോ?
അത് ജോയിൻസിൽ അങ്ങനെ പ്രശ്നമില്ല, എല്ലാം ജോയിൻസ് ആണ്. 7. Number of joins is equal to 7. Okay, number of joins is equal to 7. So look at the figure and remember the concept, and there you can see total number of links, that is equal to 6, and total number of joins, that is equal to 7. Substitute and you will get number of degrees of freedom is equal to that will be equal to anyone? Number of degrees of freedom. 1. Number of degrees of freedom will be equal to 1. Number of degrees of freedom will be equal to 1. Now you will be able to see the question number. You can see the question number B. So you look at the figure, concentrate on the figure, and you do by yourself and say the total number of degrees of freedom. First you calculate the number of links, then you calculate number of joins. There two concepts are there. So calculate number of joins, then calculate degrees of freedom in the figure 1.7b.
N is equal to 2.
Yes, very good. Your name?
Aditya Tiwari.
Aditya Tiwari, very good.
Thank you, sir.
See, n is equal to 2. See how you will calculate. See, first thing is you should know the concepts. See, നേരത്തെ ഒരു ട്രയാങ്കിൾ ഷേപ്പ് വന്ന് അതേപോലെ തന്നെ ഏതെങ്കിലും ക്ലോസ്ഡ് ഫിഗർ ദാറ്റ് ഈസ് ഹാച്ച്ഡ് മീൻസ് ദാറ്റ് ക്യാൻ ബി കൺസിഡേർഡ് ആസ് എ വൺ ലിങ്ക്. ഓക്കെ, ദാറ്റ് all the fixed links എന്ന് പറഞ്ഞാൽ ലൈനിന്റെ അടിയിൽ ഹാച്ച് ചെയ്തിട്ടുണ്ടാവും. ലൈനിന്റെ അടിയിൽ യു ക്യാൻ സി 1 1 1 1. all the fixed links, they are counted as one link. All the fixed links, they are counted as one link. So that concept you have to remember while solving the problem. So what about the number of links? Number of links will be 7, and number of joins that will be 8. 1 minute. Okay, number of joins will be 8. So anyone having any doubt in the figure 1.7b?
സർ ഒരു ഡൗട്ട് ഉണ്ട്. ഈ അഞ്ചാമത്തെയും രണ്ടാമത്തെയും ആറാമത്തെയും നമ്പർ കൊടുത്തിരിക്കുന്ന ലിങ്ക് ഫസ്റ്റ് ഫിക്സഡ് ലിങ്കുമായിട്ടല്ലേ കണക്ട് ചെയ്ത് കാണിച്ചിരിക്കുന്നത്? അപ്പൊ അതെല്ലാം കൂടെ വരുമ്പോ അതൊരു ടെർഷറി ആയിട്ട് ക്വാട്ടർണറി ആയിട്ട് വരത്തില്ലേ?
അതെല്ലാം പൊസിഷൻ വേറെയാണ്. പക്ഷെ നമ്മൾ ഫിക്സ്ഡ് ലിങ്കിനെല്ലാം ട്രീറ്റ് ചെയ്യുന്നത് all the fixed are considered as single link. Okay, all the fixed links, they are considered as single link. കൗണ്ട് ചെയ്യുമ്പോൾ നമ്മൾ 1 1 1 എന്നും പറഞ്ഞാൽ ഫിക്സ്ഡ് ലിങ്കുകളെല്ലാം കൗണ്ട് ചെയ്യുള്ളൂ. ഫിക്സ്ഡ് ലിങ്ക്സ്, all are fixed links. That is why we name it as 1 1 1 1. But whenever you take joins, there is one joint at the point 1. നെക്സ്റ്റ് വണ്ണിൽ വേറൊരു ജോയിന്റ് ഉണ്ട്, നെക്സ്റ്റ് വണ്ണിൽ വേറൊരു ജോയിന്റ് ഉണ്ട്. അതുകൊണ്ട് അവിടെ 3 ജോയിന്റ് വരും.
Okay, sir.
So number of links is equal to 7, number of joins is equal to 8, number of degrees of freedom is equal to 2. Okay, number of degrees of freedom is equal to 2. So you try to solve the C figure 1.7c. Try to solve it. Only by solving n number of problems you will understand how simple all the problems are. Try to solve figure C.
N is equal to 0.
N is equal to 0. Aditya Tiwari, right?
Yes, sir.
Oh, good. N is equal to 0. N is equal to 0. Number of degrees of freedom, that is equal to 0 in this case. So look at the figure C. There you can see 5 links. Once you are aware of the links, you need to calculate the joins. So by looking at the figure, it is very clear. There are 6 joins. You can look at that small dark circles, black colored circles. You can see all are joins. 1, 2, 3 in this side and 1, 2, 3 in this side. So that means number of binary joins is equal to 6. Number of binary joins is equal to 6. Number of binary joins is equal to 6. Number of binary joins, that is equal to 6. Okay, anyone having any doubt in figure example 1.7c? Example 1.7c. (1.7c). Then after completing that, do 1.7d. 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 വിവേക്
ആ സാർ.
വിവേക് ചെയ്യുന്നില്ല എല്ലാം?
ഉണ്ട് സാർ.
1.7d എത്ര ജോയിന്റ് ഉണ്ട്?
n is equal to 3.
N is equal to, no, 1.7d, it is not 3. You once more you calculate. Vivek, what about the number of binary joins in that figure? Binary joins എത്ര ഉണ്ട് വിവേക്? വിവേക് വിവേക്
സാർ 4 ആണോ?
4 ശരിക്കും നോക്കി നോക്ക്. ബൈനറി ജോയിൻസ്, ഓരോ ജോയിന്റ് അടിയുന്നോട്ട് എടുക്ക്. താഴെയുള്ള 2 ജോയിൻസ് നോക്കുക. അവിടെ വരുന്നതെല്ലാം രണ്ടും ബൈനറി ജോയിന്റ് അല്ലേ? ഓരോ കോർണറിലും നോക്കുക. 1, 2 താഴെ വരുന്ന രണ്ടും, ദാറ്റ് ഈസ് ബൈനറി ജോയിന്റ്. ഹിയർ ഓൾസോ യു ക്യാൻ സി അനദർ ബൈനറി ജോയിന്റ്, തേർഡ് വൺ.
സാർ 5 ബൈനറി ജോയിന്റ് ഇല്ലേ?
5 7? 1 എന്ന് പറയുന്ന പോയിന്റ് ഇല്ലേ, 1ന്റെ നേരെ മുകളിലുള്ള ആ ഡോട്ട്, ആ ജോയിന്റ്, അതെന്ത് ജോയിന്റാ? 1ന്റെ നേരെ മുകളിലുള്ളതും അതേപോലെ 2ന്റെ നേരെ മുകളിലുള്ള ഡോട്ടും, ദാറ്റ് ബിലോങ്സ് ടു എനിവൺ? ദാറ്റ് ഈസ് 1ന്റെ നേരെ മീതിയുള്ള ഡോട്ടും അതേപോലെ 2ന്റെ നേരെ മീതിയുള്ള ഡോട്ടും, ദാറ്റ് ബിലോങ്സ് ടു വിച്ച് ടൈപ്പ് ഓഫ് ജോയിന്റ്? എനിവൺ?
ബൈനറി അല്ല.
Binary, it is binary only. Okay, this one and this one, both are binary. വിവേക്
ആ സാർ.
മനസ്സിലായ?
ബൈനറി ആണ്.
രണ്ടും ട്രയാങ്കിൾ അല്ലേ? രണ്ടും ട്രയാങ്കിൾ, അപ്പൊ രണ്ടും സിംഗിൾ ലിങ്ക് ആണ്. So these two are binary. Okay, what about this one? This one, this is again binary. What about, എങ്ങനെ ടെർണറി ആവും? ബൈനറി അല്ലേ അത്?
ബൈനറി.
ആ 7ഉം 1ഉമായിട്ട് മാത്രമേ കണക്ട് ചെയ്തിട്ടുള്ളൂ.
ഇല്ല സാർ, ബൈനറി തന്നെ അത്.
ആ ഹാച്ച്ഡ് ട്രയാങ്കിൾ ദാറ്റ് ഈസ് വൺ ലിങ്ക്. അതെന്ന് പറഞ്ഞാൽ ഒരു ലിങ്ക് ആണ്. ഓക്കെ, ദെൻ വാട്ട് അബൌട്ട് ദിസ് വൺ? അതെന്താണ് വിവേകെ ഇപ്പൊ മാർക്ക് ചെയ്തേക്കുന്നത് 5ന്റെ താഴെയുള്ളത്? ദാറ്റ് ഈസ്
ബൈനറി തന്നെയല്ലേ?
ബൈനറി. വാട്ട് അബൌട്ട് ദിസ് വൺ? 4ന്റെ 8ന്റെ എവിടെയുള്ളത്? ദാറ്റ് ഈസ്
ബൈനറി തന്നെയല്ലേ? ഹാച്ച്ഡ് ട്രയാങ്കിളിന്റെ ഒരു ലിങ്കും
മറ്റേ ലിങ്ക്. ഇനി ഇത് നോക്ക്, 8ഉം 3ന്റെ എവിടെയുള്ളത്? 8ഉം 3ന്റെ എവിടെയുള്ളത്? അതെന്താണ് വിവേക്?
അതും ബൈനറി.
അതും ബൈനറി. ഓക്കെ, so that all are binary joins. What about the other joins? This one,
ടെർണറി ജോയിൻസ് അല്ലേ സാർ ബാക്കിയെല്ലാം?
ബാക്കിയെല്ലാം it is ternary join. So what about anyone? What about the total number of binary joins? Anyone? Total number of binary joins. Total number 11. Yes. 7 plus, you can see yellow colored this 7 plus 2 into 2, because one ternary joint it is equal to 2 binary joints. So total number of joints will be equal to 7 plus 2 into 2, that is equal to 11. 7 plus 2 into 2, that is equal to 11. Then what about number of degrees of freedom? What about number of degrees of freedom? -4. Total number of links is equal to 8. Total number of binary joins -1. It is -1. Okay. Number of links is equal to 8 and number of joins is equal to 11. 3 into 8 minus 1. 3 into 7. That is 21 minus 2 into 11. 2 into 11 means 22. 21 minus 22, that is equal to -1. That is your answer. Okay, so last one you solve yourself. Last one. First, it is clear from the figure, number of links is equal to 8. You calculate number of joins. Number of binary joins calculated. Calculate number of binary joins. Anyone? Number of binary joins?
ഇന്നല്ലേ സാർ?
Yes. So മനസ്സിലാവാത്തവർ നോക്കുക, ജോയിൻസ് കാൽക്കുലേറ്റ് ചെയ്യാൻ. ദിസ് ഈസ് യുവർ ഫസ്റ്റ് ജോയിൻ, ദിസ് ഈസ് യുവർ സെക്കൻഡ് ജോയിൻ, ദിസ് ഈസ് യുവർ തേർഡ് ജോയിൻ, ദിസ് ഈസ് യുവർ ഫോർത്ത് ജോയിൻ, ദിസ് ഈസ് യുവർ ഫിഫ്ത്ത് ജോയിൻ, ദെൻ സിക്സ്ത് ജോയിൻ, സെവൻത്ത് ജോയിൻ, എയ്ത്ത് ജോയിൻ, ninth joint and 10th joint. Okay, likewise 10 joints are there. All are binary joints. So 10 binary joints and 8 links. What about the number of degrees of freedom? What about number of degrees of freedom?
1.
Number of degrees of freedom will be 1. Number of degrees of freedom will be 1. Okay. Number of degrees of freedom will be 1. So you do one thing today itself. After this class, you solve all the problems. I will send all the answers. First you solve by yourself and then look at the answers. And still if you are having any doubts, you contact me today itself and this is there for your mid examination, these problems. Okay, so it is in your group. Whatever we have discussed today, all the problems, questions and answers, everything is in your group. Okay, it is in the PDF format. So go through it. First you solve by yourself, once more you solve by yourself, and if you're having any doubts, you look at that PDF and try to solve all the problems. And if there is any doubt, today itself you ask and clear all the doubts. Okay. Okay, today's absentees.
Okay, sir.